Okay, so it should look like that. All right, so to do a 90-degree rotation, the rule is right here. XY becomes negative YX. So you change the sign on the Y. You don't change the sign on the X. You just change the sign on the Y and you flip them. So what's going to happen in negative 2, 0? It's going to become negative 0, which there's no such thing as a negative 0, so it's just 0, okay, with a negative 2. Okay, what's going to happen to C? Negative 3, negative 4. Yeah, there you go. Negative 3, negative 4. You change the sign on the Y, then you flip them. Nothing changes the negative on the 4. Okay, what happens to the Z? Negative 4, negative 3. And then the X? Negative 4, negative 1. Okay, so we've got 0, negative 2 is going to be my B prime. Negative 1, 2, 3, 1, 2, 3, 4 is the C prime. Okay, negative 4, 1, 2, 3 is the Z prime, and then negative 4, negative 1 is the X prime. And it looks like that. Thank you, ma'am.
They just tell you that, no, even tell you.
Okay, next one. So negative 5, negative 2, negative 4, 1, 0, negative 1, and negative 2, 1, 2, 3, 4. Okay, so negative 5, negative 2, negative 4, 1, 0, negative 1, and then negative 2, negative 4. Yep, okay.
I'm sorry.
You're good. So we have K, A, I, J. Now, on this, we are reflecting over the line y equals x. And y equals x is this line right here. All right, so if you remember the rule on reflecting over the line y equals x, you just switch the x and y. Don't change the signs or anything, you just switch them. So this is going to turn into negative 2, negative 5. This is going to turn into 1, negative 4. This is going to turn into negative 1, 0. And this is going to turn into negative 4, negative 2. Yeah, this is going to turn into a mess here. K prime. 1, negative 1, 2, 3, 4. Negative 1, 0 is the I prime, and then 2, 3, 4. Turn to the J prime. That may seem weird, but turn it like this, just think about going straight up and down. You can see how the red and blue in there is symmetric around that line y equals x. See how it's a flip across.
Bless you.
Thank you.
Bless you.
Thank you. Okay. So last week we talked about, what are the three that we talked about last week? Okay, translation.
Oh, yeah.
Oops, sorry. Translation, rotation,
Reflection.
and reflection. Good. Whoa, not reflection. Reflection. Okay. So those are the three we talked about last week. All of those are what we call isometries. None of those change the shape or size. They stay the same. You just slide them, you flip them, you turn them, but they stay the same shape, same size. Today we're going to do a transformation that does change the size. It won't change the shape. It'll be similar, but it does change the size. So let's look over here. A blank is a transformation that enlarges or reduces a figure. So today we're going to talk about a dilation.
When you get small.
Okay. Well, it can get bigger or smaller. Okay, so the scale factor is the number multiplied to increase or decrease the size. Okay, the scale factor is the number you multiply to either make it get bigger or to make it get smaller. So if the scale factor is greater than 1, it produces an enlargement. It's going to make the figure bigger. If the scale factor is less than 1, and we're assuming we're not dealing with anything negative here. We're not going to have any negative scale factors because if you go far enough negative, then this doesn't work. But just assuming all of the scale factors are positive, if it's less than 1, what do you think? It's going to produce a reduction. It's going to get smaller. Bless you. Okay? So, for instance, on number 1, we're going to use a scale factor of 3. Is it going to get bigger or smaller? It's going to get bigger. That's greater than 1. On number 2, we're going to be using a scale factor of 1/2. Is it going to get bigger or smaller?
Smaller.
Smaller because it's less than 1. Okay? All right, so on number 1, go ahead and plot those 3 points and connect them to make that triangle. All right, so it should look like that. Now, what we're going to do is we're going to do a dilation of this. And as we already said, it's going to get bigger. So what we're going to do is we're going to use a scale factor of 3. And all you do is you're going to multiply every single number up there by the scale factor. So every coordinate, every number in the coordinates is going to get multiplied by 3. So I'm going to multiply -2 times 3. I'm going to multiply -3 times 3. I'm going to multiply 3 times 3, -3 times 3, 4 times 3, and 2 times 3. Everything gets multiplied by the scale factor. So what is -2, -3 going to turn into? Good. -6, -9. That's what this one turns into. Okay, what is -3 going to turn into? It's going to turn into 9, -9. And then what's 4, 2 going to turn into? It's going to turn into 12, 6. Okay? So let's plot those new points. And yeah, that last point, 12, 6, is going to go off the grid. Just kind of estimate where it should be at. So it should look like that. Okay, now let's look at this first one that we had here. Let's just find a side that's easy to count. Let's start off with this side right here. How long is this side on that triangle?
5.
1, 2, 3, 4, 5. Okay, good. So this one is 5 units long here. Okay, how long is that same side but on the new one, on the dilated one?
15.
It's 15, which makes sense. Why does that make sense? Good, right here, by the scale factor of 3. 5 times what gives you 15? 5 times 3 gives you 15. So that's what I said. The scale factor is the number you multiply to increase or decrease the size. So all of the sides got 3 times as long. And we'll talk about area and stuff like that in our next unit, but for what we're doing here, just the sides increase by what the scale factor increases by. Okay? All right. Go ahead and plot these 4 points on number 2. All right, so you should have something that looks like this. Now, we already said that since the scale factor is 1/2, that this is going to get smaller. It's a reduction. And we do the same thing here. Everything gets multiplied by 1/2. So what is -8 times 1/2? It's -4. So this is going to turn into -4. What's 6 times 1/2? 3. What is -6? -6 going to turn into? -3, -3, because -6 times 1/2 is -3. What's 4 -2 going to turn into? 2 -1, and then 8 10 is going to turn into 4 5. All right, so let's plot those new points. Okay, so there you go. So you can see it's a reduction. So what I want to do real quick is I want to find the length of this side right here. And the reason I'm doing this side, there's no sides that are just horizontal or vertical, so they're not going to be that easy. But I'm just going to do a quick Pythagorean theorem thing here real quick. So this one is 2 here, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. So 2 squared plus 12 squared, square rooted. Hop that in your calculator real quick and tell me what that is. Tell me the length of that line. $12.16. No, you're good. You're good. Okay, and then I'm going to do the same thing on this one right here. Okay, this is 1, and this is 1, 2, 3, 4, 5, 6. So 6 squared plus 1 squared, square rooted. .08. Okay, so what do you notice about these two numbers right here? 6.08 is exactly half of 12.16. Okay, and again, that goes back to this right here. Scale factor is 1/2. Okay, so on the back, what we're doing here is we have both of them graphed and we're looking for the scale factor. Now, what's important here is it's talking about from A to B, okay? From A to B. So you have to think about that. That's important. All right, so from A to B. So A is the bigger one, B is the smaller one. So first of all, going from A to B, is that an enlargement or reduction?
Reduction.
It's a reduction, okay? Now, the next thing we want to do is we want to find the scale factor. What did we have to multiply A to get B? Okay? All right, so let's find a side that's easy to count, which this side is going to be the easy side to count because it's just straight across. We can count that. So on A, how long is that side?
6.
It's 6. On B, it's at a half there. It's at a half there. So how long is that side?
3.
3. Okay, so the question is, on A it's 6, and on B it's 3. So I'm thinking, okay, 6 times what number gives me 3? Yeah, it's half, right? So that tells me on this problem that the scale factor equals 1/2. Because I'm thinking 6 times what gives me 3? It's 1/2. Or another way to say that is like this. 6 times x equals 3. Right? I'm looking for this number right here. So how would I solve for x? If we were just doing normal algebra stuff, how would I solve for x here? 6 times x equals 3. Yep, just divide by 6, right? That way these 6's turn into 1. And what's 3 divided by 6? Is 1/2, right? It's just, I'm just giving you the same way to solve the same problem right here. Okay, next one, from A to B. So on this one, here's A and here's B. So is this an enlargement or reduction? It's an enlargement. We're getting bigger. So on A, how long is that one? 3. On B, how long is it?
4.
Is 4. Okay, so what I'm saying here is I want to know what I have to multiply 3 to get 4. So 3 times some number equals 4. 3 times some number equals 4. I want to know what that number is. So how do I solve for x here? Divide by 3. And it's just 4/3. I mean, that's the answer. So the scale factor is 4/3. Scale factor is 4/3. Okay, on this one from A to B, here's A, here's B. Is this an enlargement or reduction? enlargements. How long is that side on A? 4. How long is that side on B?
5.
It's 5. So 4 times some number equals 5. Or I could write it as like this. 4 times some number equals 5. Divide by 4. And it equals what?
5 over 4.
Equals 5 over 4. So the scale factor here is 5 over 4. I mean, you could type that in your calculator. In fact, let's do that. I just want you to see this. If I do 4 times 5 over 4, it gives me 5. See, that's what I'm saying. Is 4 times what number gives me 5? Because the one on A is 4, the one on B is 5, and 4 times 5/4 gives me 5. So the scale factor is 5/4. Okay. On this one, so here's A, here's B. So from A to B, is that enlargement or reduction? It's reduction, definitely getting smaller. So how long is that side on A?
2.
My bad.
You're looking at the wrong one. That's 6. B is 2. You're good. Yeah, you're just looking at the other one. Okay, now remember it's from here to here. So I'm thinking, all right, 6 times what number is 2? 6 times what number is 2?
3.
Okay, and you're thinking about it backwards because 6 times 3 is 18.
You said 3 2, so be quiet.
Okay, you're good. Y'all are good. You're thinking, though, that's good. So 6 times what number gives you 2?
You divide by 6.
Divide by 6, just like we've been doing. And 2 over 6 just simplifies to 1/3. And again, if you do that, if you type in 6 times 1/3, that will give you 2. That's what we're looking for. 6 times 1/3 is 2. Okay, so real quick before you group up, let me get you started on this assignment. So this is exactly like we were just doing. And the same thing from A to B. So A is like the small triangle here. This is A, and then B is the bigger one. So first of all, from A to B, is that enlargement or reduction? It's enlargement. Okay, so how long is this side on A right here?
4.
It's 4, and then B goes all the way across here. How long is that one?
9.
8.
Is 8.
I think you got it right.
Okay, so again, I'm trying to figure out 4 times what gives me 8?
2.
Is 2. So this one's easy. Okay, 4 times what gives me 8, and that's easy to see. It's 2. The scale factor on this one is 2. Okay, on number 2, from A to B, this is A, this is B. Is that enlargement or reduction?
Reduction.
That one's reduction. How long is that side on A?
6.
It's 6, and on B, it's half and half, or 1, 1, and then a half, half, so that's 3. So I'm thinking, all right, 6 times what gives me 3?
1/3.
6 times what gives me 3? It's half. And again, if you just do the little algebra thing, it's like this. So the scale factor here is 1/2. Okay, so that's what you're doing on those. Okay, on number 1, on all these right here, you're plotting those 4 points, and then this right here is your scale factor. So you're going to multiply everything on number 1 times 0.5. So everything's going to get cut in half. On number 3, the scale factor is 2. So on that one, you're going to multiply everything by 2. On number, that's number 3, my bad. Number 2, I'm sorry, the scale factor is 1/3. Everything gets multiplied by 1/3. So you'll just type that in like, 0, 0, but nothing's going to change there because 0 times 1/3 is 0. But on B, you're going to do 3 times 1/3 and then 3 times 1/3, which will turn into 1, 1. Type that in your calculator. 3 times 1/3 is 1. Okay, you can get grouped up and go for it.